Hi, and welcome to my guide on how to build this 5 kilowatt electrical kiln, which can be heated up to more than 1000 degrees Celsius. It can be used to melt metal, burn out ceramic shells and casting molds, and so much more. And of course, marshmallows. The first step is to find an old oil drum and empty it from its contents. My brother Sebastian found an almost empty drum which has been used for almond oil. Much nicer than old diesel. The bottom of the drum will be used for the lid, while the other end is going to be the bottom part of the kiln, facing down to hide its openings. Both parts are cut plenty oversized and can be cut down to the exact sizes later, when the insulation has been mounted inside of them. Here you see Sebastian cutting off the half which will be used for the lid using our beloved angle grinder. The bottom part of the kiln will first be insulated with a 25mm layer of biosilicate, which is cut into a circle from a larger sheet. The biosilicate is a very good thermal insulator, but also a bit fragile, so it will be covered by a layer of fire bricks next. The lid is used as a template to draw a circle with a Sharpie. This can then be cut out with a sharp knife using several passes. Before moving on, the biosilicate insulation can be test fitted using the lid. As this layer of insulation is needed both for the bottom part and the lid, another circle is cut out. To save on material, I used the leftover insulation, which I had to piece together and test fit, as you can see here. Heat-resistant cement is used to mount the biosilicate to the bottom of the oil drum. Before doing this, the inside of the drum has been cleaned with alcohol to remove any leftover oil. For the bottom, I decided to use the jigsaw pieces of insulation and save the solid piece for the lid. Gaps are filled up with more heat-resistant cement. The next layer is a 50mm thick fire brick, which is much more sturdy but less insulating compared to the biosilicate material. This layer will be made of 4 fire bricks cut to fit the inner diameter, like shown here. The radius is marked and can then be cut out with a regular handsaw, one that you're not too emotionally attached to, as it will never be the same again after having cut through all the fire bricks. I do the cutting a bit rough, and then any jagged edges will be just filed away afterwards. Now we got these 4 pieces which can be fitted together, and off camera I made another 4 to be mounted in the lid afterwards. The insulating fire bricks can be mounted with heat resistant cement, and how much of this is still a mystery for me, but in this case gravity is in our favor, holding the fire bricks in place. So I think we'll be alright. Note that the fire brick surfaces have been slightly wetted with water, as the cement adheres better to a damp surface. The bottom is now covered with 75mm of insulation, and we can move on to the side fire bricks, which will both act as insulation and holding the heating elements at the same time. Here's one fire brick placed at the bottom of the kiln. 8 of these will be placed around the circumference, creating an octagon shape. Repeated 6 times, and here you can see inside the construction, revealing the 6 layers with grooves for the heating elements, and diagonal grooves for the heating elements to go from one layer to the next. The keen eye will notice that there is no diagonal slot between the middle due to the heating element being split into 2 separate sections, which will be discussed in more detail in part 2 of this series. Each fire brick is made from these standard pieces measuring 65 by 114 by 230mm. The sides are cut at a 112.5 degree angle to form the octagon shape, and then the back side of the fire brick is cut off to make it fit inside the inner circumference of the drum. On the inside of the brick, a slanted groove for the heating element is cut. The size of this groove is determined by the diameter of the heating element, which will be designed and made in the next video, where we'll be aiming for a diameter of around 11 mm. 6 of these blocks have a diagonal groove, making it possible to feed the heating element from one layer to the next. I figured that cutting grooves before the side angles was the most efficient approach, and I like being efficient when having to cut 48 bricks. The groove could be cut by hand, but it's so much easier with a table saw where the blade angle and height can be set. After cutting the outer sides of the groove, I adjusted the table saw a bit to make another 2 slits. And finally the blade is tilted to create the slanted edge for the heating element to rest in. Now it's just a matter of repeating this 48 times. The slivers left behind can easily be broken away with a screwdriver, and the heating element from the future can be test fitted in the groove. The firebrick side angles will be cut with the help of this 3D printed jig I made to make it easier to repeat these cuts 48 times. If you're interested in the 3D model for this jig, please let me know in the comments and I'll find a way to make it available to you. As mentioned earlier, cutting these bricks is very tough for the saw blade and it will quickly become dull. Here you can see a new blade compared to the one used to cut all the fire bricks. Next, the fire bricks are filed a bit to smooth the outward facing edges, making them fit more easily inside the drum. 6 of the bricks need to have the diagonal grooves cut into them, which I will do according to my working drawing, where all the dimensions are listed. This is done by hand and did not take that much effort. Next, holes in 4 of the 6 blocks with diagonal grooves are drilled. This is done on bricks for layer 1, 3, 4 and 6, where the heating element wires will enter the grooves. Here you can see how the 6 bricks will be stacked when mounted in the kiln. Note that in this clip not all grooves are facing the right way up. This is fixed by simply swapping some of them. After some days of cutting and a lot of dust, all 48 bricks are now ready. The heat-resistant cement is again spread generously in a circle where the fire bricks are to be placed. And as before, the fire bricks are made slightly wet on the mating surfaces before applying the cement and putting down the bricks. Gaps are filled up with some fireproof putty, which is the same material as the cement, just a bit more firm and easy to put in the gaps by hand. Before moving on to adding more layers of fire bricks, I realized that it's a good time to cut holes on the side of the drum where the heating elements will connect through. Doing this now saves the hole saw from cutting into the abrasive fire bricks being added afterwards. I've marked the center for each of the holes and start by drilling some guide holes. All of the exact dimensions and 3D model of the entire project will be made available in the final part of this video series. Drilling these big round holes with a hole saw was no easy task on the curved surface and due to the thin material. On the middle of the drum this was even worse and no pretty sight. This again called for the angle grinder as a last resort. With the holes in the drum sorted, the bricklaying process can now be continued just as before, paying attention to picking the correct block for the heating element to change layer. The last brick in each layer is always a bit tight, and some of them needed a few millimeters to be shaved off to make them fit. Again, more of the heat-resistant putty is applied around the edge and in all visible gaps between the bricks. and then we can move on to the third layer. At this point I realize the whole kiln is getting quite heavy, approaching 30 kilograms, and will most likely be more than 70 kilograms when done. So it's better time to order a heavy duty oil drum caster if this monster is ever going to be moved around. The next 3 layers are quickly completed here, so you won't have to see me lay every brick. This is all the fire brick work done for the bottom half of the kiln completed, and as a final step the steel drum is cut flush and using an angle grinder. The steel edge should not be too high anywhere, as it will prevent the lid from closing and sealing properly. This was all for part 1 of the electric kiln build series, and we're now ready for part 2, where the 2 heating elements will be designed, made and mounted into the kiln. Thanks for watching and see you soon.